Hi ladies, today we're going to continue with section 8.3 and we're going to talk about how putting together what we learned last time, we're going to put it all together so we can actually plot the graph of quadratics in the form ax squared plus bx plus c. Okay, so I want you to write these steps in this box here in your notebook. And these are the steps that we're going to take to plot these graphs. So, right, the first thing that we have to find is our vertex. And then based on the sign of A, whether it's positive or negative, we're going to determine whether or not our graph opens up or opens down, which will tell us whether that vertex is a minimum or a maximum point. We're going to determine our axis of symmetry and a y-intercept, and we're going to use that information to plot our graph, and then we're going to describe our domain and range for these graphs as well. Okay, so again, put these steps in your notebook, put a nice box around them, some stars, highlighters, whatever you can do to let yourself know that this is the important information to determine in order to plot a quadratic graph in this form. Okay. All right, so we're going to start with an example, 5x squared plus 10x minus 3. All right, so A is 5, and that's positive, B is positive 10, and C is negative 3. All right, so since our A value is positive, we know that our graph or our parabola will open up. Okay, so our vertex point will be a minimum. Okay, that'll be the lowest possible y value for this parabola. So let's start by finding our vertex. So vertex, and we need our x value, which is equal to negative b over 2a. So negative b over 2a. Okay, so in this case, negative b would be negative 10. Okay, over, oh, that was an accident. Okay, that would be negative 10 over 2a. And a is 5. So that's just negative 10 divided by 10, which is negative 1. All right, so now we need to find the y value of our vertex by plugging negative 1 in for x. So we have 5 times negative 1 squared, which negative 1 squared is just 1. So 5 times 1 is 1, plus 10 times negative 1, so that's minus 10, and then minus 3. So 5 minus 10 is negative 5. Negative 5 minus 3 is negative 8. So our vertex is the point negative 1, comma, negative 8. Our axis of symmetry, right, is negative 1. The line x equals negative 1. And then our y-intercept is going to be equal to our c value, which is negative 3. So let's go ahead and plot these points, or these values. So we need the vertex at negative 1, negative 8. So here's negative 1, and then 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then our y-intercept is going to be negative 3. So down 3, 1, 2, 3. All right, which means we can plot a mirror image point right here. Okay, And then we just draw our parabola through it. Okay, not the best looking parabola, but you guys get the point. And then sort of later on in the chapter, we will learn how to figure out what exactly those x-intercepts are as well. But for now, I just want to see your axis of symmetry, which in this case is the line x equals -1, so this line here. Your y-intercept, the mirror image point, and that vertex point. All right, let's try another example. So first thing that we want to look at is our a value, which is a -1. So that means our parabola is going to open down. Okay, so a is -1, b is 4, c is 12. So let's go ahead and start by finding our vertex. Okay, so plug in our values. So the x value for our vertex is -b, which is 4, over 2 times a. So 2 times -1 is -2. So the x value for our vertex is going to be +2. All right. Now we can solve for the y value by plugging +2 in for x. So we get -2 squared. So 2 squared is 4. So we get -4 plus 4 times 2, which is 8, plus 12. All right, so the y value for our vertex is 8 minus 4 is 4, plus 12 is 16. All right, so we will count up by 2's here on our x-axis since we have such a high value. So 2, 4, 6, 8, 10, 12, 14, 16. All right, so our vertex is going to be the point 2, +2, +16. So we're going to go all the way up there, right? Our axis of symmetry, right, is going to be x equals 2. So that line, x equals 2. Right, and then we want to solve for our y-intercept, and our y-intercept, right, is going to be equal to our c value, which is +12. So don't forget that we're counting up by 2's here. 2, 4, 6, 8, 10, 12. So we're going to plot that there, right? And then we're going to go to the mirror image point. So we're going to go 1, 2, okay, and then 1, 2. So it should be mirrored across that axis of symmetry. And then we can just go ahead and draw our parabola. Okay, through those points. Okay, so y-intercept was at 12. So 0, 12 would be the point. All right, so our vertex was the point 2, 16. And I'm realizing on the last graph, we didn't talk about our domain and range. So domain is all possible x values. So domain for these parabolas, right, will be all reals. Okay, so all real numbers. There's not a number that you could plug in for x that wouldn't give you a y value. All right, so the domain of these parabolas will go from -infinity to +infinity. The range, however, right, we have a maximum value here for our parabola. So the highest that we can go for our y value is 16. Okay, nothing will go above that, but below that we can have any possible value. So our range goes from negative infinity up to 16. So that would be your range. Okay, so you always have to take that vertex point into account for your range, whether or not it's a minimum or a maximum value. So we can go back to this last example here and talk about domain and range. So again, domain, right, is going to be all reals. So from negative infinity to positive infinity, there's not a number that you could plug in for x. That wouldn't work for this equation. However, right, for this vertex point, we have a minimum value. So nothing for y would go below negative 8. Okay, so our range is going to be from negative 8 up to infinity. Okay. All right, let's do one more example. So again, we have a negative value for a, so that means our parabola will open down. So that means we're going to have a maximum point. All right, so the first thing that we want to do is we want to solve for our vertex. So we're going to plug into our equation, right, negative b, so that's a negative 2 over 2 times a, so 2 times negative 1/2, which is just negative 1. All right, so you get negative 2 over negative 1, which gives you a positive 2 for your vertex, for your x value. For your y value, right, we have to plug that 2 in to here, right? So 2 squared is 4. 4 times negative 1/2 is negative 2, plus 2 times 2, which is 4, plus 16, right? So that gives us a y value of 18. So again, we're going to have to count up by 2's. So let's do that. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, make sure we have some of those labeled so we remember what we're counting by. Okay, and our vertex is going to be the point 2, 18. So let's go ahead and plot our vertex, right? And that's also that line there, that vertical line is our axis of symmetry. So our axis of symmetry is the line x equals 2. All right, and then we just need to find our y-intercept. And again, our y-intercept is going to be 16. So remember, we're counting by 2's, so this is our y-intercept. Okay, and then we're going to count, we're going to find our mirror image point. So we go 1, 2, okay, has to be at the same y value, right, but equidistant from that axis of symmetry. So 1, 2. All right, and then we're just going to draw our parabola through those points. Okay, and then let's talk about domain and range. Okay, so domain, again, all reals. Those x values can go from negative infinity to positive infinity. Our range, however, right, is dependent upon our vertex. So our vertex in this case is a maximum value, and the maximum value is 18. So our y values will never go above 18. However, right, we can go as far down as we want. Let me erase that little mark there. So that means that we can start at a value of negative infinity and then go up to a maximum value of 18. So that's domain and range for a quadratic parabola. So if you have any questions, as usual, feel free to email me, and I hope this helped. Thanks a lot.